Well, that's because we were busy talking.
Obviously. All right, guys. So we get a better understanding of electrical control of pneumatics, but this carries over to hydraulics. What I have done is actually wired a system. I have 24-volt power. I have a 3-way 4-position directional valve. I have reed switches, or well, actually they're just reed switches that are mounted to the cylinder, and I also have micro switches that are reading position on the cylinder as well. Now, I have momentary switches that activate it. I have lighting to indicate position. The thing I want you to truly understand and look at is how it's wired. That means you got to get off the seats, hit your feet, and get up here next to Mr. Teets.
What do you think about all that? Oh, that poetry question, that's helped you.
I is a poet.
Do you know it?
No, and it doesn't pay any better either. Now, what I want you to really understand is these essentially would be a 4-wire reed switch or proximity switch. All right. So what it utilizes, you have to have, now if it's 24 volt, you got to have 24 volt present. Then it's going to use, depending on whether it's an NPN or PNP. PNP is going to use positive signal out. NPN is a negative signal out. And that means that whatever the first letter is, it's going to be what's used as a source for the normally open or normally closed contact that exists. Come on up, Alberto. If they stink, tell them. Otherwise, just come on up. All right? So I really want y'all to get a good understanding. The other thing is, John, if you can take that loose there and pass it around. This is the 4-way 3-position directional valve. Just don't look at the front. If you look at the front, you're going to be kind of misguided. You need to flip it over and actually look at the directional valve that's in behind there. The other one here is a 4-way 2-position. Now, you got it in your hand, it's passed around. What's the difference between the two, other than what I just told you?
2-way and a 3-way.
2-position and 3-position.
2-position, 3-position.
All right, but what constitutes the difference?
Cylinder return.
That one has 4-way.
2-way, cylinder automatic return.
So what does that mean?
Less leads? Not sure.
On this one, the cylinder returns.
All right, but all right, he was onto something but didn't elaborate any further because he's not certain.
Right.
All right, he said it had 4 leads. The other has 2.
Right.
So what does that mean?
Sources of electricity.
All right, we're getting there.
That were in the 2
You can
different
only
sides.
control it in one
Mr.
direction.
Kelly, come on. Jump in there and help bail him out. Come on. Bail him out.
You can only control it in one direction.
Well, if I have 2 sets of leads coming into it, means what?
You can control it in both directions.
Right.
All right,
Sending and subtracting.
and maybe have 2 coils.
2 quarters. Yeah.
Ah, the Paul Harvey. I know y'all younger whippersnappers and some don't know about old Paul. However,
Don't feel bad, I didn't know either.
I'll attribute that to other things, not you. Now,
Well, I'm sorry, that don't go.
the one valve, and what it would be good for is the fact, this one, which is a 2-position 4-way valve, all right, is when I activate it, it's going forward. All right, I can control the motion forward if I was to hook it up correctly. As soon as I take power off of it, or if something happens that the voltage leaves, it's coming back and it's staying fired back. Or depending on how it is plumbed, it may stay extended. Does that make sense? If you're looking at the symbols over here,
Why would you want it to stay forward?
I just said it depends on what you have. Now, the one we're using is here, and the other one here is here. So here's what we have. All right.
3 positions.
Oh, I'm glad you cleared that up. Look at you go.
Bigger, smaller. See, we're getting there, we're getting there.
Are you positive? I'm not sure.
Absolutely.
All
This
right.
center is blocked, correct?
Yes. And John, turn the air off, if you would, sir. No air, no power, and the cylinder's somewhat being held. I mean, you can compress the air some. And the reason you can compress the air, how much pressure is over there, John?
Not now. Was 17.
17 PSI. Now you probably think, well, why is he running so low pressure? Very good question, Mr. Kelly.
Isn't 17 PSI environmental pressure? What?
No, that's.
So, looking at the two combinations that we're using right now,
You got one?
depending on how I, yes, sir.
So this is blocked,
It's positioning right now.
right? That's why we can't push or pull. So what would happen if we were using this one right now? What would it do?
You would have already retracted back as soon as you let off.
Okay.
Or be fully extended.
And stay there.
As soon as I take the power off.
Okay.
Pretty generous guy today.
All right. Now, did everybody look close and see? All right. The other thing you'll notice, if you look real close, you see how it's configured. It's real close. It looks like, wait a minute, I might be able to bolt that other than on here. Anybody else notice that? Look close at how it's put together. You're making noise.
I usually do, I'm that kind of guy, I don't know.
All right, but now let's look deeper into what we have configured. Does everybody understand what we're doing here on the reed switches? All right, what are we doing, Mr. Kelly? Come up and explain the wiring, sir.
Oh, wiring, I'm not sure about. Are those the reed switches down in the bottom?
You just said yes. Illustrate, dear sir.
I know about the lights and the
How
conditioning.
will you feel more comfortable? I know you're a safe kind of guy.
I mean, once it gets there, it's obviously gonna turn on one light on. Coming back, it's gonna turn on the other light.
All right, how's it doing that? So I could pull all these wires off and they still come on? You just said by moving. All right, well, so cylinder moved, but if I take the wires off, I can still move the cylinder.
It's got a magnet in it, though, so it sits in the magnet.
Good answer. All right, but we gotta understand how the wiring is configured. Remember I was mentioning about NPN? What type of signal is going out if I'm doing NPN? Good job. So if it's PNP, it's, all right. Now, if you look close here, this is coming from a positive source, which obviously is firing the coil, which we're jumping off to our source, which is the white connection on this switch. Now, in the field, we're not going to have little banana jacks. We actually have to look at the schematic that's on the reed switch. Your young eyes can see that with no problem. Us more mature individuals, we got to get the helpers out sometimes. However, we'll have 4 wires, sometimes we'll have 3, and we have to wire them accordingly. We have to look at which one is normally open, if they have a normally open or normally closed contact. If, a lot of times, it's one or the other, depending on what we ordered. All right? So, we have to be diligent about what we do in the wiring of them. You'll find some that's only 2 wires. All right? But I want you to understand and feel comfortable about the use of momentary switches how we can actually, and if you, here's, let me do this. Now, Mr. Dick, if you'll take and make the extend micro switch. What's going on?
Just reading up cylinder.
The retract one, please. Release it. See what I've done? I prevented the valve from being energized with the micro switch. I have it in the circuit. Using what type of contact? Normally open or normally closed? Don't look at the switch. Is it correct or incorrect?
It's correct.
Is that because you looked at the switch?
No, it's because when you shut the switch, you break the continuity in the circuit. If you had it wired the other way, you would make continuity.
As soon as, exactly.
Yeah.
So it wouldn't allow movement thereof.
Yes, because you have no current, you have no voltage.
We're disrupting the positive circuit for the directional valve through the micro switch. As long as nothing is on the switch, I can bump either one of these. All right, it'll work either direction.
If you hold it down, if you hold one end down, put it in the middle.
It is in the middle. I got both of them down.
Put it in the middle off of the switches. There, now press one down. No,
Push
the
it.
trigger, not the button.
These?
Yeah.
Oh, you mean at the same
Press-
time?
No, press one down. Now hit the button. Let go of one.
Well, no, that's the reason I was looking to see which one you let go of. So
Yeah, I'm trying to get somebody's finger caught.
that's the reason I was looking. Well, you see, I'll put my finger there for this one. You adjust it to 100 PSI for his run. All right, now, at what pressure do you reckon we'll start overrunning the switches? You know, so, Mr. Kelly, I'm not seeing you very active with our lab activities, so
Take the
I
floor,
was hoping to
man.
do a
Catch up days.
you're running out of days, my brother.
What was the question?
Catch up starts now, ready, set, go.
At what pressure do you presume that we will start overrunning the switches? We're at about 17 currently.
Yeah, somewhere right around 15, 17.
Might move past the switch.
In other words, it'll
Any
move so
direction.
fast it'll overshoot the switch.
It's got a lot of force behind
It's also mechanical. Can it even go that far with the cylinder? Yeah.
John, turn it up to 20, please.
Because when the L stops, running it off.
I'm gonna guess 20.
I'm against 20.
Why did the Pneumatic change the speed?
More pressure.
By 3 PSI.
It doesn't take much when you're dealing with air. Now, the key to this is, this system's capable of 120 PSI.
The system or the pause?
All of the above. John, turn it up to 40, please.
That route will be staying where you're.
Yeah, and step aside.
Now, he's safe.
Yeah.
Now, this is 1/3 of its capability.
Okay.
One-third. Now, most systems out in industry run at 100. Go ahead, we'll try it. We won't do many at 100, but,
Run the,
At 120.
huh?
John, they told Kennedy he was safe that day.
Actually, it's as far as it'll go, and it's probably somewhere right around about 98.
And I didn't hold the button the whole time. I'm bumping it.
Got some kick.
almost instantaneous.
Again, that's just on a bump. I didn't do. Now, we want to control this. Mr. Kelly, how do I control it? I want to keep 100 pounds or 90, what we have, John?
Probably right around 98.
98 pounds of pressure is what I'm going to maintain. How do I control the speed?
Stop it.
I want to control it again. I want to be able to stop on those switches. And if you look, it's actually lighting up the coil. That's the other thing you all didn't notice. If you look in behind here, look in there, take a you see that little red light come on? If you didn't get to see it, come on. This is what I want y'all to get a chance to see so when you're troubleshooting. See a little light on the coil in there for the plug?
Yeah, I see it.
You see it, Mr. Torres?
Yeah. Okay.
All right,
Well, the other side too.
come on. If you haven't had a chance to see it, I want you to see it. See the red light? There's a red indicator in there to show you that the coil is being energized. All right? Now, that means it's overrode my switch on the extend. Because if it was on the switch, it won't move.
Lights working on this side now.
Now the other side, because I can hear the solenoid, I can actually hear the spool move. That noise, that's a spool inside that directional valve shifting. So I'll ask you again, you got a team of friends here.
We're changing it to normally open, like the circuit's normally open work.
Is that going to help him, team?
You're gonna add something to the circuit,
What am I going to add to the circuit to control it?
the pneumatic circuit.
And
That's not exactly what I'm looking for, because John has that right there on the manifold.
Flow valve?
That's a pressure regulator, isn't it?
I think this is a flow valve.
It's a pressure regulator. The flow valve, that's the valve control on the side.
This one?
Yeah.
There you go. So your team's trying to help you. He's looking for the component.
Flow valve.
Flow, come on, put it all together here for me.
Flow control valve.
Speak up.
Flow control valve.
See how it just flowed out? Flow control valve. Because I'm trying to control the flow, but I don't want to affect the
Pressure.
good job. Because I need to move something, so it still needs to have almost 100 pounds of pressure to move it. I just don't want to drive him through it. Because what would happen if I run that plunger into the box at the speed it's moving now? I have a whole lot of damaged product and unhappy customers at the end of the day, right? So we need to control it. So I turn this off, and I'd probably turn the air off, and I could add, maybe a couple more small lines, but I could add a flow control in here for the extend. And then I had to add a separate one for the retract. Or I have to put it in line here, right? Is that correct, sir?
But if you put it in there, you still won't get your 100, you won't get your 100.
Well, I won't.
You won't?
If I put a flow control in,
Still get the pressure.
Oh, you still
Not
get
the
the pressure,
pressure,
but not the-
not the volume of it.
but not the volume of air.
That's
So
not-
that controls the volume, flow controls the volume.
so it's like,
See, you just pulled something in, because you all used flow controls with your hydraulics. Right? You're supposed to have. And you used a pressure reducing valve with your hydraulics. I believe, maybe this was the one device you used? All right. That ring a bell? But the other one there had the red knob on. So that I could adjust the pressure with this, right? You control system pressure or one side with just pressure. So now you get to see how this relates. Because we want to be able to control this within a window. And that's what we're doing. We're using micro switches to prevent us from being able to continually engage it. We're using reed switches to determine position. All right. Now, if we had it hooked up differently, we could probably use these, but we'd have had a secondary set of contacts to take and service both the indicator and position. But there again, there's another little device, it's like a brick. I think it's one sitting back there on the top of my shelf there. That little light gray brick type thing. What is that thing called?
PLC.
Oh,
Is that what it is?
Yeah. I don't know.
Oh, y'all got to get some confidence going on here.
I'm trying to remember what that stands for.
That's PLC.
All right, that's a PLC. Now, you can use some apprehension because they actually have what they call programmable relays. Look a lot like that AB 1100 that he just picked up. Now, if I had the PLC, I only need this to indicate to the PLC, actually these, is all I need to the PLC to control both the valve and the indicator light, right? That makes sense, or everybody agree with that statement or disagree? Now, we touched on PLCs a little bit in the intro class. You didn't get to do the intro class, but there's a thing called relay logic and ladder logic. They emulate each other somewhat, but there is inherent differences. All right? So if we was using a PLC that was set up on here, we could actually run our banana jacks. We wouldn't have as much spaghetti all over the place. We only need one set of contacts or indicators. It wouldn't matter if there's micros or whether there's reed switch. Clean the whole system up then, right?
So in other words, you're taking out mechanical switches, using PLC.
PLC, I still need an input to indicate extend and retract. All right? But then I can use the reed switches, which are on the cylinder, instead of putting something out here in the path of the cylinder. Now I've freed up the whole end of the cylinders performing the work.
Or you could use,
Or I could use those.
or a photo eye.
Or a photo eye. Yes, sir.
a quick-handed got nothing but two-person.
Sometimes we're smarter when we don't say it.
Gotcha.
Did I say that too loud?
Could you use a math instruction to measure?
Well, you're gonna use math all the way through it.
Well, instead of using, with the PLC, instead of using our semi-switch, could you use a math instruction within the program to say, okay, after 1 inch of movement, stop?
How do you determine 1 inch of movement?
Well, you
Or
would
confirm
have
it.
to,
You're calculating over time, given X amount of pressure, that it's going to travel X distance through X amount of time, right?
And you have no way of confirming it that way.
well, there's other variables, so.
No, I'm working on his equation, then I'm going to go to the variables. So now when I have a valve that sticks a little bit, my air pressure is not at 98, it's at 132. Tomorrow it's at 87. Next day it's 125. Next day it's 75. Lunchtime it dropped to 50. You know, the alarm went off, but they're still trying to get it going, and it's building back up slowly, but they're going to get it going right. Got a little hot in the compressor room. System has a cutout switch, so it gets to 45, it can't work, but you know, we're at 57, and I have my math's all set up for 90. You see where I'm going with this?
Yeah.
You know, and this is one thing when it comes to PLCs, a lot of timer-based stuff. If you have something that is specific to timing, I have a process specific to timing, that's great. when I'm trying to time a function, I'm gonna get in trouble. The cylinder starts getting wear to it. The slide that may be pushed against got a little dust in it. So it took more pressure to move it the same distance. There are so many things, as Mr. Cameron Sutton here was throwing in here, that very correct. There's so many variables. I mean, let's face it, mathematically we can pretty much determine everything, right? But we're going to be within 80% of accuracy generally, depending on what we're calculating, something that has a considerable amount of variables with it, all right? That's the reason they call us statisticians, statistical process control. I mean, we know the window we should be in, and we give ourselves some parameters probably to fall within, right? Because we know that we're not going to be right on that number every time. We need to have a window of opportunity.
I mean, you could technically, because you could set up a parameter for every single PSI. You could set up a parameter for half PSI from 100 to 50 PSI, and you could make it, you know, it could see a certain PSI. And
Now I need an analog input to know the pressure though.
so
That's a lot of mathematics, and it's all simplified with a discrete input. What's discrete mean? You ought to know. What's the rest? See, you ought to know.
Signals on the valves, like.
Discrete and analog is the two types of
Analog
inputs.
is on or off, discrete, it's got like a range.
The other explanation.
Huh?
Do the opposite answer.
Oh, the 4 to 20 milliamp? Where you can turn it up and
The
down,
opposite answer of what you just said.
turn it down. and
What's analog?
on and off.
The opposite answer.
Oh, so the analog is where it's variables and then.
Good answer. Variable. There you go. 4 to 20 milliamp. Minus 10 to positive 10. 0 to 10. You had the right idea, but wrong.
Oh, I said I'm in
You
backwards.
said it backwards. That's
All right.
what I kept saying. The other way, but it just didn't sink in, Jeff. But good answers. A discrete is on-off light switch. A simple discrete switch, all right, prevents a lot of mathematical programming. Because think about what you're saying, and think about what you've done in the programming, and how much time would I have to do all the calculations for distance.
a lot.
Now I put a reed switch on it, and I'm done. Right? Now when John has to go out and troubleshoot it, and you put all that math in, and he looks and he says, "What fool did all, this paper's still on the floor, and I'm holding, what was he thinking? This dude just didn't have no time for anything else."
Would you really call me a fool?
Hey, no, you need to get in here.
I think fool would be nice.
But that's always OCD.
I'm only speculating, but I'm sure fool would be one of the least used
I'd just call
terms.
you. I'd just call you.
He'd call you, then call you. Call you this, and then,
And then his paper will be going all the way to the floor.
yeah. The first piece of equipment I got to see that was PLC controlled, we had what they called a dog bone. It was actually a door pull for a Chrysler product. It was rotational molded skin. It was foamed with a steel insert inside. All right. Well, the dog bone cutter used all time, and what it did, it had a disc cutter. It was about 3.5 inch in diameter, and it had to make basically a square pattern, but it used pneumatic cylinders and would shift the bed underneath over time. He didn't use any reed switches. Well, this thing was trying to cut through metal and everything else because the air pressure was deviating. It would bind a little bit and was not doing position. You ever get halfway through the stroke, next thing you know, that 3-inch blade, you hear, there goes that blade. Change the blade out, and we call them up, and it's right out of Winchester. I won't say the name of the company. Those fellas kept coming up and says, "You all, what are you doing to it? It works fine every time we come up." No, sit here for a while. Because the guy, he'd make some adjustments, and he'd go back to Winchester. And we were in Strasburg. As soon as he wouldn't even get out the door, you hear, "Oh!" There's another blade. It charges $30 a blade. I told the supervisor, I said, razor knife, and it's done. We gotta use the equipment, they bought it. Go ahead. But it don't work. I said, exactly. How you use something that doesn't work? You got 2 blades left. That means 2 more parts. And how functional you reckon that metal insert is after we gouge into it with a blade that's cutting the metal up? I said, come on. I said, they didn't do their homework when they put it together. They did time versus position and essentially shot themselves in the foot. And that was when I decided, look, I need to learn this PLC stuff. I said, y'all need to give me a copy of it for the laptop we have for maintenance. And I said, I'm gonna learn it. So myself, Ray Klein, and another fellow named Jake Davis, we all started teaching ourselves through trial and error PLC programming. And once we got to see some other equipment that come in, and you start looking at how they did their ladder logic, it started making sense how things were functioning and what they needed to do to function. But the thing is, we as a team need to be able to look at something, determine how it's working. I know you're able to do it. You're actually working on your car, adding, forced induction to it. You're going over and above the factory. I mean, you have more problems with some of the tubing, but it'll get there. It takes time and seat time to get it where you want it.